we're going to look at the rate of change of position. So in simple plain English, this means how quickly is the position of an object changing. Right, let's just redraw this curve of the car. So we had something like this. There's the car's position with respect to a certain point of reference, and this was time. And we said the car, its position changed something like this with time. Now, let's look at an interval over here. So let's say that is T1, T2. So the car has moved from this position x1 to that position x2. And let's look at another interval. Let's call it this one. Let's try to make it approximately the same size as that one. So let's call this T3 and T4. And in that interval, the car moves from this position, which is x3, to that position, which will be x4. Now, if these two time intervals are the same, one can clearly see that in the interval T1, T2, we get a larger change in position than in the interval T3, T4. So, intuitively, we can think, well, for a time, so the time that elapsed between T2, T1, we get a change in position, which is equals to x2 minus x1. Here, for the time interval T4 minus T3, we get a change in position, which is equals to x4 minus x3. Now, if these two intervals are the same, we can see that this interval is clearly smaller than that interval. So we get a smaller change in position in a certain amount of time. So if I change my position by a lot in a certain amount of time, it means I have to move rather quickly. So if we look at two straight lines, one that passes through both of those points, one that passes through both of these points, which one of those lines has got the steepest slope? The first one. So here we know whatever is moving quicker. Here we know whatever is moving slower. So this allows us to now define what's called the velocity of an object. And the velocity of an object is literally the rate at which it changes its position with respect to time. So we will define the average velocity as being equals to the change in position divided by the time interval in which that change of position happened. Right. Now, just to remember, a change in position has got a direction. So if I move from here to that door, I will be changing my position, or my change in position will be to the right. Similarly, velocity has got a magnitude, so how quickly, literally, we are changing our position with time, plus a direction telling us in what direction is this change occurring. So just remember, velocity, as to specify something's velocity, I need 2 bits of information. If I just tell you you're moving at 4 meters a second, it means you are moving 4 meters from where you were every second. But you can move in this direction, that direction, behind, in front. All of those are possible. The only way to really specify and be accurate about your motion is to say that you are moving at a certain rate in a certain direction. Then everybody knows what you are doing. So just remember this. Velocity always has got a magnitude and a direction. Now, let's look at an example that incorporates this idea of velocity and our idea of displacement. And let's just see what comes out of this definition. So let's say, just try to imagine that you are a 400-meter athlete. So you're going to run around an athletics track. So there's our athletics track. Here's the start. There's you. And you now set off when the starter pistol sounds, and you start running and running and running and running, running. Right over there you see someone you recognize in the stands, but you decide to rather finish the race. So you keep on going and you stop right over there, and you ran these 400 meters in world record breaking 38 seconds. Right, so you feel pretty good about yourself and your own effort. But if you start out over here and you run all the way around and you end up right where you started, what's your change in position? 0. Great. So if your change in position, let's write it like this, change in position is 0. If we defined our average velocity as being change in position over the time interval, what was your average velocity? 0. There's a lot fewer people saying 0 this time around than there was before. But this is our definition. This is how we defined it. We said, well, whatever my change in position is over a certain amount of time, if I divide that by the time it took me to change my position by that much, I get my velocity. And here we find that the average velocity was indeed 0. And you will feel extremely cheated. You just broke the world record, and here I'm telling you, well, on average you really did nothing. So what's going on here? The problem is well, it's not a problem, but why we feel cheated is because of the way we've defined average velocity. And there's a way around this. So let's define a new quantity called distance. Now this is the length of the path that is traveled in a time interval. So with our athletic example, the distance traveled is actually 400 meters, because that's the length of the actual path you ran. So the time interval was 38 seconds, pretty amazing. And now we say, well, what is the average rate at which you traveled a certain set distance? So we call this quantity speed, and it is given by the distance traveled divided by the time interval it took to travel that distance. And in this case, this would be 400 meters divided by 38 seconds. And this gives us something like 10.5, I think, whatever, seconds. So pretty good. Now what this means is during the 38-second interval, on average, you traveled 10 point whatever, sorry, that's meters per second, meters every second. So that's pretty quick. So be careful of these two things. We always define a velocity as our change in position in a certain amount of time. And that's the quantity that can make you feel cheated. Because if you start out from some point and you end up right back where you came from, your position has not really changed in the time interval, which means your average velocity was 0. Another way to think about it is you spent equal amounts of time traveling in one direction and equal amounts of time traveling in the other direction, and the two cancel each other out. However, when we define speed and distance, we don't care in what direction you're traveling. You could be walking in a small little circle. If after a certain amount of time you have walked 400 meters, we divide that by the time interval it took you to travel that path, and it tells us what your speed was. Now, to show you a